Hi, I'm back again, and we're going to finish this spreadsheet example that we've been working on. So I'm going to open the file a little bit differently. I'm going to launch Excel. I'm going to go to the File pull-down menu, and when I do, one of the options I have on the File pull-down menu is to choose Recent, and it'll show me a listing of the most recent spreadsheets that I've been working on. And the most recent one here at the top is Module 1 EX2GB. If I click it, I'm back to where I left off. Now, a few things I want to point out. You'll notice that I put in a formula and copied it. It copied in a relative way. That's an important point to understand, relative copy versus absolute copy. Something else that I wanted to point out is that when I use a formula, it will treat any cell that it references. If the cell contains an empty value, there's nothing stored in the cell, then it'll treat that cell as having a value of 0. So for instance, right here for test 3, okay, so test 3 for Moses Horowitz is stored in cell E2. Currently, there's a value of 100 stored in cell E2, and if I were to go to that cell, delete the contents, it would treat it as though it stores a value of 0. Okay, so again, if I have 3 tests and I weight the average of the test at 60%, then each individual test would be contributing 20 points toward the 20% toward the total grade. So if I put in if I don't put anything in this cell, it calculates to a value of 79.6667. If I put in a value of 0, hit the enter key, same thing, so it didn't change the computation. And if I put in a value of 100, then it's going to raise it by 20 points and make it 99.6667. Okay, so hopefully that's clear enough. When formulas reference an empty cell, they treat the cell as though it stores a value of 0. Now, I say that because let's take a look at something else. Let's take a look at using the average function. One of the things that spreadsheet users need to do frequently is to calculate the average of values stored in cells. So there is a built-in function called the average function. Average, and do this differently. I'm going to put in a label here, average. I'm going to move over here to test 1. Okay, so I'm going to put in the average function equal average. Now, if I'm using a function, I could type in the first cell in the range, in this case C2, then put in a colon and follow that with the last cell in the range C6. So I could say C2 colon C6, or I can simply begin the function, and as soon as I type the left parenthesis, drag down and then close it off, and the spreadsheet program will fill that in for me so I can avoid typing. And it tells me the average is 62. Okay. I'm going to put in a value of 0 here. It tells me the value is 55.4. I'm going to change this 0 to an empty cell, and it tells me the value is 69.25. So what's going on here? Well, in short, what's going on is that whereas formulas treat empty cells as though they store a value of 0, functions treat empty cells by ignoring them. And in this case, it would find the average by dividing by 1, 2, 3, 4, And here, if I explicitly put in a value of 0, it sums everything up and divides by 5. So again, formulas treat empty cells as though they contain a value of 0. Functions treat empty cells by ignoring them. And if you don't understand that rule, which seems to be inconsistent, but if you don't understand that rule, you could potentially make a huge mistake. And if you think that just leaving that cell empty is going to be equivalent to 0, it could impact especially the calculation of an average. All right, so hopefully that's clear to you at this point. And now we're ready to move on with what we were doing before. And what I want to do is calculate or have the spreadsheet program look at the weighted average and assign a letter grade of A, B, C, D, or F. I also want the spreadsheet program to look at the weighted average and determine whether the student is passing or failing. So we're going to, again, pretend that this is a graduate course and that in order to get a passing grade, you have to get a C or above. And we're furthermore going to pretend that according to my grading scale, a 70 is the lowest possible C value. Anything below 70 is going to be a D. So it might be possible for a person to get a D and still fail when I have this completed. So let's do this part first because this is the easier of the two functions to write. There is, and I'm going to show you where to find these. There is a library of functions that are available, and if you go to the home page and on the editing ribbon, you'll see there's a summation symbol, and to the right of it is a pull down arrow. Click there and it'll show you the 5 most recently used functions, and then there's more functions available. So if the function you're wanting to use is not among the 5 most recently used, then you can click on more functions and it will take you into the help files where you can either get some kind of superficial help on how a function works, or you can drill down and get help in much greater detail. So it's going to show me a list of the most recently used functions here. That's a list that extends beyond what was shown previously. But I can filter other ways. I can filter for all functions, in which case it'll show me every function in the function library, and it'll list them in alphabetical order. If I know what category a particular function is in, then I can filter for functions of that category and eliminate a lot of the clutter in the list. And I happen to know the function I want to use is a logic function. So there's a category called logical. If I choose it, in that list of logical functions is the function I want, the if function. And if I click on that in the list, it gives me a very, brief explanation of how that function works. It shows me the general form of the function. It begins with the keyword if, and there are 1, 2, 3 component parts that the function uses, and the term that's used for the components of a function is the word arguments. So I would say that the if function has 3 arguments. It begins, when I write the function, it begins with the keyword if, and then following that is a left parenthesis and an argument list. And in this case, there are 3 arguments, and those arguments have to be inserted in a specific order. The first argument has to be a logical test, sometimes called a Boolean expression, and that'll be an expression that evaluates either true or false. If the expression evaluates true, then whatever I insert for the second argument comes into play. If the logical expression evaluates false, then the second argument is ignored, and whatever I have in place for the third argument comes into play. So again, the if function is going to begin with the keyword if, then there will be a logical expression that evaluates true or false. If the expression happens to evaluate true, then the second argument will be performed, and if it evaluates false, the third argument will be performed. Now, that's probably all the information you need once you see this demonstrated. But let's say that I demonstrate this and you're asked to do something similar, and you go back and say, I really don't know how this if function works very well. That's not enough of an explanation. If that's the case, then you can double click on the if function. I believe. Let me cancel that and try it again. Okay. We'll go to more functions. Again, the if function. This is where I should have gone. There's a hyperlink down here, help on this function. If I click on the hyperlink, assuming that I have access to the internet, it's going to go out to a server that is maintained by Microsoft, and it's going to show me help for this function. Now, having done that, it's not seeming to work. So let's try it one more time. There it is. Okay, that's what I should have seen. I don't know why it didn't do that. But what I want to point out is that if the initial information it gives you is not enough information, then you can drill down into the help files, and these things are very, very good. There's probably going to be more information here than what you're going to need, really. They will show, they'll give you more in-depth description of how the function works, and they'll also show you some concrete examples. In this case, they're showing at least 4 examples. So that's the way the help files work. The other thing is, if you're ever using functions in Excel and you have attempted to get help through Microsoft's help files, you're still not understanding things, you can always do a Google search for Excel functions, and there's lots and lots of material on the internet about Excel functions. So that's yet a third way to get information. All right, so I'm going to go ahead and put in a function here, and I want it to look at the value. In this case, I want the function to look at the value that's been calculated in cell L2, and if it is greater than or equal to 70, I want it to display pass, and if it's less than 70, I want it to display fail. So how do I do that? Well, all formulas and functions need to begin with an equal sign, followed by, if it's function, a keyword. And as I type the characters in, I'm not inserting any spaces. Embedded spaces are off limits with both formulas and functions. Don't embed spaces in either a formula or a function. So equal if, and I have to put in some kind of logical test, something that will evaluate true or false, and I'm going to test the value in cell L2. If L2 greater than equal 70, there's my logical test or my Boolean expression, comma, the second argument now. If that's true, I want it to display pass, so I'm going to just type in PASS framed in double quotes. That's known technically as a string literal. So I'll have it display the string literal pass, comma, and now it moves on to the third argument. And this is what happens if the expression evaluates false, and I'll have it display the string literal fail. Close off the argument list. So it's equal if, and then inside of parentheses is my argument list. There are 3 arguments, first one being a true-false expression, second one being what happens if the expression evaluates true, third argument being what happens if the expression evaluates false. And if I hit the enter key, we see that Moses there will pass, and that is what we would anticipate. Now, if I drag down by the fill handle, it's going to copy this function in a relative way. Since I'm copying down a column, it's going to change the row coordinates, and that same basic function is going to get copied into each of these cells. The only difference being that as I copy, it changes the row coordinates. So it's looking at L3, then L4, L5, and L6, and as I would anticipate, everybody is passing except for Samuel Horowitz. Okay. Now, let's look at how we would assign letter grades. A little bit more complicated. The solution to this problem, there's more than one way to solve this problem in Excel, but if I want to use a decision function, then I'm going to have to nest functions. That is to say, I'm going to have to put a decision function inside of a decision function, inside of a decision function, inside of a decision function. And in general, this hopefully makes sense and will help you think through the solution to similar problems. In general, if I have multiple decision points, I'll have to nest functions, and in determining how many functions I'm going to need to use, what I should consider is the number of possible outcomes. So in this case, there are 5 possible outcomes. I could give an A, a B, C, a D, or an F. And in order to construct this nested function based upon 5 possible outcomes, I'll need to use 4 functions. In general, you will use n minus 1 number of functions where n is equivalent to the number of outcomes. So in this case, n being equal to 5 possible outcomes, it's going to require that I use 4 functions. And here's how it's constructed. Begin with the equal sign, followed by if. Okay. Now, I need to provide my first Boolean expression, logical expression. I want to check the contents of, in this case, L2. Check to see if L2 greater than equal 90. If that's true, I want to assign the string literal A. If it's not true, maybe I need to assign a B, a C, a D, or an F. I don't know what to assign. I have to make a further decision. So along this false path, I'm going to have to insert another if function. So if, again, look at L2, and this time test and see whether it is greater than equal 80. If it's greater than equal 80, if that's the case, then I'll assign the string literal B, and if it's not, I may need to assign a C or a D or an F. I don't know which. I'll have to make another decision. If, again, looking at L2, check to see if it's greater than equal 70. If it's greater than or equal to 70, then I'll assign a C. But if it's not, and this is then the third argument with respect to the, in this case, third decision. If it's not greater than equal to 70, then I may need to assign a D, or I may need to assign an F. So I'm going to have to make one more decision. And I'll check to see if, again, L2 is greater than equal to 60. If that's the case, then on the true path of the fourth if, I will assign the string literal D. And then on the third argument of the fourth if function, I'm going to assign the string literal f. I really don't need to make any further decision. If it's not an A, and it's not a B, and it's not a C, and it's not a D, then there's no need to decide any further. The only option I have is an F. So there's 5 possible outcomes, A, B, C, D, F, and in order to make the decision, I have to use 4 nested if functions. And now at the end of this whole thing, I'm going to close off the parentheses. So I close off 1, 2, 3, 4 parentheses, strike the enter key, and it's calculated in A as it should for Moses. And as I drag down on the fill handle, it's going to copy that expression into all the other cells and make the adjustment to the row coordinates. And I see that Samuel gets a D and everybody else gets a C. Now, spreadsheet programs, you know, kind of heartless. I had mentioned in the previous video that I would probably give, you know, these two guys a B because they are within a point of having, you know, a high enough score to get a B. So as a human being, I could exercise a little pity. Spreadsheet program's not going to do that. It's strictly going to look at the rule and enforce it. And the other thing to, you know, make note of here is that whereas it has assigned a letter grade of D, this being a graduate course, that's still failing. Okay, so there is the grade sheet example. We've seen the effect of empty cells and how they impact formulas and functions. Make sure you understand that detail. We've looked at the help files, some of the online help that's available through Microsoft, seen how to access it. We've looked at the construction of functions. In general, functions will begin with an equal sign followed by a keyword. Then there will be a parenthesis, and what's contained within parentheses is known as the argument list. That could be one or more arguments. If there are more than one argument, the arguments will be separated by commas, and the arguments represent the components that the function uses in performing its task. All right, I think that wraps up this spreadsheet, and with this you should have all the information you need to complete assignment number 1.